Well, hi everyone. So welcome to our first English talks of the day. Today we're going to talk about QEMU, and it's going to be a bit different than what was explained on the website. Miu's going to explain it for you, but it's going to be a part that is a talk and then the workshop where she can out on the Discord. I'll put all the details in the chat. So welcome Miu and enjoy the workshop. Thanks everyone.
Thank you. So let me just have my share screen on. So hello everybody. Today I'm here to talk with you about emulation, specifically how to emulate firmware, IoT firmware or router firmwares using Docker and Qemu. So I didn't invent this. I've been doing a lot of research to find a way to excuse me. So how it happened is I had so much problems using Qemu with the different tools that actually use it and that we can find available on the internet. So I made some more research and I found a video from IoT Village made by Ilya, where he explains how he used Docker and Qemu together to emulate his IoT firmware file systems. So before we go further, I will just start with a bit of introduction with who am I. So my name is Miu Ram, for those who know me. You can find me on the Hackfest Discord. And if you have any questions after this presentation, just please don't hesitate to ping me and ask me. I joined this year the Hackfest team as a CTF designer, and I'm really happy to announce that I'm sharing with you today for those who do the CTF. I'm sharing with you my very first challenge tonight. And what I do in everyday life when I'm not doing some other stuff is hacking IoT. Since I've started in the cybersecurity field, my first challenge was to learn about the Internet of Things, how they are insecure, and in order to find ways to, of course, upgrade the security of those the devices. So since then, I've been grinding levels and I've been grinding skills in different fields in cybersecurity and IT in general. And I've done already a lot of conferences at the Hackfest 2020 for those who were there, and at Izaka and others. And this one is my very first one in English. So please bear with my English, which can actually become some Franglish at some bits. So let's get started and see how it works. So a firmware is like what I call a tiny OS. It's made like small and small enough to be able to run on low memory and low energy devices as IoT. So basically, it's a combination of all the code that needs to run on a device. And how does it look like? Well, the firmware is made out of the bootloader, which will start initializing the device and everything. It will pass the poke to the kernel, which at his turn will be initialized in the file system. So in IoT, some of the most IoT architectures that we find are actually ARM and MIPS. And we will learn more about how we emulate those during this presentation. Oh, I just forgot to make to explain how this presentation will be done. So I will first start by explaining the procedure, all the setuping and all the things that it requires to do this emulation. And after that, we will jump to the Discord. And for those who want to try it with me and have questions, I will be available for the next hour and answer your questions. So before we continue, why we need to perform firmware analysis. So when trying to understand the device and perform some security analysis on it, the firmware gets really important, and it's a way to, as I said, better understand the firmware, find some hidden secrets in it, as the passwords, as API key, API links, and certificates, etc. And there is also a way to find vulnerabilities by analyzing and reversing the different binaries in the firmware or the entire firmware itself. And the way to um, try to see how those binaries work and better understand the device is by doing emulation on those binaries or the entire firmware again. And one of the ultimate for like for bad person perspective, why they would need to do firmware analysis. Well, of course, to understand the first steps I just named, but the ultimate goal for a bad actor would be to create a malicious firmware which can be flashed on the device. So to get to Docker and Qemu work together, we need the different softwares, starting with binwalk to do the extraction of the file system, or hexdump and DD, which is another way to do it too. We will need, of course, Qemu, Docker, and to set up our Docker and Qemu to work together, we will need the image multi-arc Qemu user static from Dockerhub. And for this example, our target will be D-Link. It's a MIPS architecture, and it's a 30 bits architecture too. So the file system we have is a squashfs file system, and we will see how it's going, how we will make it, how we will get all those informations when analyzing a firmware. So let's start to see how we set up our environment. I have a setup.sh that I wrote for those who want it. I can share it, but it's on the, I added it here on the presentation. So first, the very first step, as we see here, is install binwalk, and then Qemu and Docker. It's pretty straightforward. You can find tutorials on the internet about how to do so. And especially for Docker, you can go to the documentation website of Docker and you will find everything you need. What we will be interested in especially is here at line 43, install Docker and 47, excuse me, setup Qemu for Docker. This is the very important step in the setuping, which will allow Docker to work with whatever it needs to do some multi-architecture emulation. So what we have to do in here is first install some specific requirements for Qemu as IRM, MIPS, since our target is MIPS. If we have x86, Qemu system x86 too, since it's the system we have and we're running on, and Qemu utils. The next step is just to run the multi-arc Qemu user static image from Dockerhub with privileged arguments. So what it does is it will update the local proxys fs, and the link you can see just right here, with all the dependencies we will need from that given image. So what this will do, it will set up our computer to be able to do the emulations using Docker. So that's like the secret between getting Docker and Qemu to work together. And then here I left some web links to help those who want to set it up. You can go to the GitHub of binwalk and Qemu website for those two. And as I say, the installation of Docker is pretty straightforward, and it's available on their website. So the next step to start our emulation is to create a Docker work-dir. I made a typo there. It's not word, but work. So this directory we'll have all the files, the directories, and the binaries we will need to perform our DockerxQemu emulation. So the first one would be the Qemu binary for the target architecture. We will need the extracted file system directory and the Dockerfile. So just a note here that we are not trying to emulate the entire firmware binary. We're really going for the file system because, as I said earlier, a firmware has a bootloader and a kernel in it, and Docker won't allow to use those since it has and uses its own stuff. After that, we have the Docker file that we need to write with, which will look a bit like this. We're going from scratch, and we will simply add the file system directory to the slash of our image. We will also copy the Qemu binary that we need for the target architecture inside that file system at user-bin. And the last step would be simply running the Qemu target architecture static a binary on with busybox from our file system. Busybox is a really important word here because it's the way we will be able to get a dynamic access to the firmware. So what is it? Busybox is a Swiss Army knife for embedded Linux. It's very tiny, and it's a combination of common Unix utilities. It's the place where we will find all the commands we used to use in daily basis for example. So it's very small and executable, and it provides a complete environment for the embedded systems. We will see more about it when I will be doing my demonstration. So the next step after that would be to build our image and then to run it and see what is the output that we get when we do so. So without waiting, I will jump to the demonstration. I have already got my Docker work directory ready. So I have the root fs file system that I have here. If we go in it, we see that I have a full-blown file system with all the directories. If I go inside bin and do ls, I see here that I can find my busybox binary. We can perform a file command on it to get more information. So as we can see, our busybox is a 32-bit architecture on MIPS. And what else we need to know here is if I list all what I have in my binary folder, you can see that every binary in here is a reference to busybox. So why I say that busybox is very important, by running this binary, we will be able to use all those commands on our file system. So without waiting, we'll go back in here and see our Docker file. It's a cat. It really looks like how what I've showed you in the presentation. We're adding the file system directory to the slash here. We're using Qemu mipsel static, and we moving this one inside the user.bin /bin directory, and we just execute the busybox binary using the Qemu mipsel static. So in here, I kind of spoiled a bit which binary from Qemu we will be using. And in this case, it's Qemu mipsel static. Before explaining why, I want to show you an example. So all the, if I do ls user bin like this, we can see that we have this. Nope. Here we go. So we can see all the architectures we can be using, we can be targeting with Qemu. We have ARM here. We can see that the MIPS architecture, we have MIPSL that we just seen here, and we have the MIPS static architecture. Before going further, I will just go back inside my Docker directory and cp from the user bin. I will copy the Qemu MIPS static in my present directory. Just trying to show something very important to keep in mind when doing this. So here, since I want to use the MIPS one, we'll be saving this. So let's try and do a first test and compile and build our Docker image. To do so, we do docker build, and let's call it test MIPS arc, and we use the current directory. Going way too fast. We give it some time, and then to run it, we go with sudo docker run t, and we give it the name. So we see here, when I do this, it gives me an error and it gives invalid elf image for this architecture. To better understand this, we remember that when I performed I first performed the file in busybox, we see here that it's the 32-bit architecture. If we do the same on Qemu MIPS static, we can see here that it's 64-bit architecture, which means we're using a MIPS. They are both MIPS, but we don't have it's not exactly the same. So in order to emulate 32-bit MIPS architecture, we will need the MIPSL one, which, if we do this, well, it still gives me the 64 bits here. But if we check on the internet, MIPSL and how to use Qemu, whenever our target architecture is a 32-bit, we will need to use the MIPSL one. So let's modify the Docker file again with the correct one, which is our MIPSL. And again, we can just again. need to run it afterward. So when I do this in here, I have an error because we're, oh, MIPS 32. Something. Oh, I did. I have a typo in here. We can see that we have an answer. We see that it's trying to run busybox when it's not, but it's not working. So what we need is to target the correct applet in order to have access to the shell of our target device. And to do so, we need to add the sh at the end of the command, which will give us access to the built-in shell. And if I do ls, I can see that I have, again, my entire file system. If I go to user and bin, we can find our Qemu mipcell static that we copied in our Dockerfile. So once we get in this to this stage, we can try and look around what can be done for all the binaries present inside our file system that runs on that specific architecture. We can try and run them on our Docker container and see how it behaves and do all kind of tests and analysis that we need to reach our goal. So this will complete my presentation of how it works. And I invite you to come to the Discord channel, Talk, Press, Q&A, where I will be available to answer your question, help you if you want to try it yourself, and do a practice all together. I will be posting this PDF right away on the Discord as well. So feel free to ping me, ask me any questions. And for those who will be present at the CTF later today, I will see you there. Thank you.
Thanks, Miu. Super appreciate it. So everyone, like said in the comments, you can join on Discord. If you don't have access already, you go to IAC access and click on the first emoji of the first text, and you will get access to all the IAC channel. And we'll see you there and at the next talk in an hour. Thanks, everyone.
Thank you.